Now the topic of this lecture is the problems on pulley block system and wedge block system. You remember in a previous lecture we have already discussed, possibly in more than one lectures, the applications of Newton's laws and numerical problems based on them. Now the pulley block system and wedge block system are examples of constrained motion, as we said before, and they also require the applications of Newton's laws, but I have decided to consider some numerical problems based on pulleys and wedge block system in a separate lecture, as we shall do now. So first of all, let us introduce the first question on pulley block system here. So this is the question, and this will be first question in our discussion now, and I number it 1. The question says, the figure shows a pulley block system placed on two smooth inclines. We are not considering any frictional force until now in our lecture, so it's smooth inclines. Draw the free body diagrams of the blocks and write their equations of motion along suitably chosen coordinate axes. Solve the equations to find the acceleration of the blocks and tension in the string. So this is the figure on the screen, as you can see, and let me put some data here into the problem. These are two inclined faces. As you can see, this one is steeper and the angle it makes with horizontal is given to be 60 degree. The other inclined face, this is flatter, less steep, and the angle of inclination is given 30 degree here. There are two blocks. As you can see, this is block number 1 and its mass is symbolically m1, that is given to be 2 kg, and this is the block number 2, a slightly smaller block, and its mass is m2, and that is given to be 1.5 kg. As you can see, there is a string that passes over a pulley attached to this inclined planes, and this string is attached to these two blocks. So this is a case of constrained motion here, and as we said before, we shall make some assumptions to make our problems easier. Let us recall them. The first is that the string is inextensible. It does not stretch under the weights it carries. Second, the string is massless. The pulley is massless and frictionless. And with these 4 assumptions, we shall proceed to solve the problem. And once again, we have to see that they are talking about smooth inclined planes, which means the frictional force is absent, and the only forces which are acting on these blocks are the forces of gravity, the normal force applied by these inclined planes, and the tension applied by the single string. In addition to that, if required, we shall also take the acceleration due to gravity, small g, to be 9.8 meters per second square in this problem. So the first part of this problem is to understand in which direction this two block system is going to move. Now there are two possibilities, like two choices. First of all, we can arbitrarily decide that the system is going in any direction, and eventually when you get the answer, if it's positive sign for that acceleration, whatever, for these blocks, if we take it this way, if the value is coming out to be positive, we can know yes, our assumption was correct. And if the value of acceleration comes out to be, say, negative, we shall know the choice is wrong. But there is a much better shortcut, because I have told you before that if we inspect this system carefully, we can guess in what direction this two block system will be moving. Now, first of all, note that the mass of the block 1 is actually more, that is 2 kg, and you can see m1 is more than m2 because m2 is 1.5 kg. But I have said before in my previous sessions on pulley block system that whenever the blocks are lying on an inclined face and not on a flat horizontal face, it is not the m1g or m2g that decide in which direction the system would be moving. If you can recall, this force of gravity acting on either block has to be broken into two components, and while the components, that is a cosine component into this inclined plane, balances the normal force applied by the inclined plane here, the force, the driving force that drags the block, that tends to drag the block down the incline, is not m1g but the sine component, that is m1g sine 30 degree here. So let me write it. In the case of block 1, the driving force that tends to drag the block down the incline is a component of m1g, and that is actually m1g sine 30 degree. That tries to drag the block down this incline. Okay. On the other hand, if I go to the block 2, again you can see the block is lying on inclined face of steeper angle, 60 degree. So even though the mass is 1.5 kg here, again the gravity force is downward, the cosine component into the plane that balances the normal force applied by the plane, while the sine component m2g sine 60 degree is acting down the incline and trying to drag the block down this inclined face here. So for block number 2, the driving force, if we could show here briefly, the driving force that tries to drag the block to down the incline on the left inclined face, that is m2g sine 60 degree. And we have to compare these two forces here to decide in what direction the system moves. So just go for a quick calculation, and I'm just showing a method to decide at the very beginning in what direction the system moves, because we have not considered any frictional forces in the problem. These are smooth planes here. So just go for a quick calculation. M1 is coming out to be, yes, 2 kg they have said. So 2 into sine 30 degree. This is the component, this is I'm writing kg into the value of g, of course, outside. This is the block 1's driving force down the right inclined face. And for the block number 2, you can similarly find out this is coming out to be m2 is given to be 1.5 kg, and that is into sine 60 degree, and these many kgs I write inside bracket, and let me write the acceleration due to gravity g outside. Go for a quick calculation and show that this quantity in bracket is coming out to be just 1 kg. Sine 30 is half, so this is 1 kg, and this whole quantity is coming out to be numerically equal to g, and that is in newtons. Of course, g is the value of 9.8. On the other hand, sine 60 being greater, that is root 3 by 2, I just tell you to show that this quantity is coming out to be roughly about 1.3 kg into g. So you can easily see here that the m2g sine 60 is numerically greater than m1g sine 30 degree. So even though m2 is smaller than m1, that is 1.5 kg, but since it is lying on a steeper inclined face of angle 60 degree, we are eventually finding that m2g sine 60 degree is more than m1g sine 30 degree, and hence we decide that the system is going leftwards. That is, the block 2 is moving down like this, and the block 1 is going up like this, and they both have the same acceleration thanks to the fact that is a case of constrained motion. They're connected by a string that is taut and massless. As I said in the beginning that if you did not go for this small work and decide that yes, 2 is going down and 1 is going up, you could have just chosen possibly the wrong direction, that is 1 going down and showing the 8 this way and 2 going up. But I said in such case, eventually we'll be getting a negative value of a that will tell you to reverse the direction. Now let us go to a separate page here and draw a fresh figure of the system and start analyzing the problem and draw the FBDs, write equations of motion, and so on.
Hello students, you got a glimpse of our video lessons through this small lecture. We have hundreds of lectures like this one covering various topics of advanced school level and intermediate physics in our website. They are exhaustive and often accompanied by elaborate diagrams to make concepts even clearer. They are taught with passion and sometimes with a bit of fun. So, at the end of the lesson, you have a commanding grip on the subject and you are ready for the board and competitive exams. Subscribe at physicsacademyonline.com to access video lectures of highest standard on various topics of physics.